Hi, welcome to another episode of Parkland Garage. I'm John Ross, the Director of Automotive Technology. It's been a while since we've seen you. We've been really busy with a brand new facility. Today I hope to show you a number of the pieces that we have here in the Park Hill Applied Technology Center. So now we're in one of the automotive training classrooms in the Park Hill Applied Technology Center. So pretty good example of what a student is going to encounter. We've got instructional space with your typical student space to sit and instructor to work with, but you can see that we have overhead projectors and computer technology to really enhance the learning environment. Lots of videos and on display kinds of lectures that our instructors participate in. But this room is really unique in the fact that you can see in the background we've actually got a car in the classroom. It's kind of one of those things that you don't typically see, that we've actually dedicated space where we're going to bring the car right in the classroom. It really helps us maximize that learning environment where we can have lecture, but then we can get up and go right to the car and really look at those pieces and parts that we're talking about. There's a lift in the classroom, so if we had an undercar class, a steering, suspension, or brakes class, we can actually do that inspection and demonstration right here in the classroom. And this would be what a student would actually experience when they go out in the workforce. If they were going to a manufacturer style training, this is what they would expect. So this portion of our facility is what we refer to as our component work area. As you can see in the background, we've got lots of different vehicle components, mainly engine and transmission or driveline components. This allows us the opportunity to work with the individual component removed from the vehicle. But you can see we've got students working in an engine class at this point, learning what those pieces are, what they do, and most importantly, how to inspect and determine if that part needs to be repaired or replaced. So made some investment in some really nice cabinetry so that we can house those pieces, so that after the student takes the engine apart, we've got all the pieces available that then they can work through their lab manuals and make decisions about again, whether or not this part needs to be repaired or how it can be replaced as they put the engines back together. So we've got an example here where we've got some students that are working in our introduction engine class, and you can see that we've got pistons and connecting rods and a micrometer, and most importantly is the lab manual. And the important part for us about learning is those students making those decisions on their own. Well, we're going to talk about how to inspect that component, what it takes to determine whether or not it needs to be repaired, but they're also in the lab here now interacting with that individual piece and filling out information, making measurements and inspections so that they can have our input on whether or not they've made the right judgment call on, is that going to be a repair, is it going to be a replacement. Now what I want to be able to show you is a typical vehicle workstation that we have created. We actually have 15 of these stalls, all with very similar applications and very similar uses. But first of all, what you're going to see is we've got computers, and so all of the service information that we have available today for our students to learn with is going to be based on electronic service information. And so this is an example of a program that we use. It's called AllData. And basically those are the directions that we need in order to learn how to take something apart, inspect it, and put back together. All the specifications that we need both from how to inspect and then to the torque specifications that we might need to replace fasteners. Then the rest of the workbench here, we've got our lift controls. So the lift is actually built into the bench and into the ground. We've got compressed air for impact and other air tools. We've got a drop light for us. We've got power and data available. Many of our students are bringing laptops to class these days, and the work surface makes it available for us to use those. And then we've got built-in tools. So one of the benefits that we have with our program is that tools are not required up front. And so we have put together a group of tools that basically go along with the functions that would happen here. Most of these workstations are going to be heavy drivetrain repair or steering, suspension, and brakes. And so you can see we've got impact and heavy tools that go with this. Nice organized facility and so on, so that we know that things are missing. Like right now you can see that someone's taken the torque wrench from here. It's very evident when I opened up the toolbox that that piece is missing. We're hoping that that also is going to drive the organization of the student when they go out into the workforce. We also then have mobile tool carts. So this toolbox then is going to have a lot of our smaller tools and equipment that we use. So you can see a 1/4-inch drive set here that would be used for the lighter use activities that we would do. But this piece is mobile, so that the workstations, the component workstations that we've talked about, we can take this over to those component workstations and use it there. So it's kind of double purpose. So this is our chassis dyno room. In previous episodes, maybe you've seen where we showed you our chassis dyno, and it was above ground attached to a lift in the other building. In this facility, then we're actually able to put that piece of equipment in the ground where you could drive a car in, quickly hook it up, and be able to use that measurement equipment. So again, a chassis dyno is kind of a neat piece of equipment. It's something that not a lot of training facilities are going to have, but we've taken the time and we're making the investment in the idea that we're going to be able to put a car on there and simulate a road condition. So we can actually load this and make the vehicle think that it's going up a 10% grade. We can make a truck think that it's pulling a 6,000-pound trailer. We could then also make the typical dyno measurements that people are used to, and that would be, the peak horsepower or peak torque. So what we have here would be Hunter's latest steering, suspension, and alignment equipment. This piece of equipment is a digital alignment machine, and really kind of a neat piece for our entry-level service program that we have. The industry considers steering, suspension, and brakes to be an entry-level skill, and we take that to the highest level that we possibly can. And so our students that are going to come through our steering suspension class are going to get trained on how to use this piece of equipment. And Hunter, within the last year, really took a turn in some of the pieces that they have. And what I want to show you is this. It's actually this alignment target that they call it, and how it actually mounts to the vehicle. Previous pieces of equipment that we used for alignments actually mounted to the wheel, and so the equipment actually would often damage the aluminum wheel because it clamped to the wheel. As you can see here, this piece of equipment actually clamps to the tire. So now we don't have any damage to the wheel. It's got a rubber mount here that keeps us from marring that up. This is the target that the machine actually uses cameras to decide where the placement of this wheel is. So this is a neat piece that we're very fortunate to have. One of few in our local communities at this point, but as people see this technology and see the benefits that it's going to offer, you'll see this standard in most facilities. The other cool thing is that this machine is actually integrated with the rack. So if you take a look down here at this, what's called a turn plate, this allows us to set tow and some other features, and this is integrated with the machine, so it actually will turn this to allow it to move when we need it to move, and when we don't need it to move, it's locked in place. So the machine and the rack are actually integrated together. So you can see in the background here, this vehicle is a part again of our steering suspension class that we have with those fundamental entry-level skills. What I want to point out to you is that the entire front suspension of this car has been taken apart. All the classes we have in our automotive program are hands-on, and that means that the students are not only going to learn about what the pieces do and how they work, but they're actually going to come out here and they're going to take these things apart. They're going to inspect those components and learn the procedures to put them back together. So hopefully it's a pretty good example of some of the hands-on skills that our students are going to get. So here we have examples of some more tire equipment, wheel and tire equipment. Again, our students are going to get applications. They're going to get what you can see here is the latest tire technology that's available, and really it's a highly used piece of equipment in our local service industry. So we've got tire machines and tire balancers. This is the latest tire machine that we have. This is a balancer, and they call it a road force balancer. And the neat piece that we have here is that this machine actually has this roller that's pressed up against the tire and can measure then basically the stiffness of the sidewall of the tire, so that we can determine if we've got a tire that's going to provide a comfortable ride for a customer, or one that maybe has got a stiff spot in it that we need to be aware of when we put that back on the vehicle. It also can help us determine where's the best placement for that tire on the vehicle as well, as far as balance and comfort for the customer. So latest technology that's available in the industry. As you can see, that's something our students are going to get access to. So now we're in our component cleanup room. As you can imagine, component cleanup is probably the dirty end of the business that we have here. We take an engine or a transmission apart, and then there's going to be some debris, and there's going to be a lot of oil and grease, and so we've actually dedicated a room to that activity. We've got tear-down benches in here. We have solvent tanks and cleanup tanks. As you can see behind me here, we actually have basically what comes down to a great big shower, and so we could take a complete engine or transmission into this area, use our pressure washer and degreasing equipment to clean that up, really before we even begin to take it apart, to try and make it as clean as possible. Over here with this stainless steel piece of equipment is called an ultrasonic cleaner. It has a chemical solution in it, and it does have a temperature control, but basically what it does is it sends sound waves through the solution and actually erodes the debris away from the component. This is going to be safe for almost any kind of metal, and we can even use it on plastic and rubber. So this is new technology coming to the automotive industry, and we were able to secure this piece of equipment, and it'll be interesting to see how we use it over the next few years. Then we have what's called a parts cleaner. This basically is like a great big dishwasher for engine components. So you can put an entire engine block in here, or cylinder heads or crankshafts. And so as we open this up, we actually can see that there's a turntable inside, and you'd put the component in there, and then these jets actually spray high pressure solvent at the component, and it spins around inside so that you can get that as clean as possible. So we're one of the few schools that's still doing live engine overhauls. So we're still working with engines that we're taking apart, where we're diagnosing and then taking apart, and then we're actually rebuilding those engines. And so this piece of equipment is vitally important to that. We also use it for our transmission work that we would do. So now we're in our engine dynometer room. Again, kind of a unique piece that they probably won't find at a lot of community colleges. But engine diagnosis and engine testing is something that we need to be able to do, and an engine dyno allows some unique pieces that we can do here that I think you're going to find other schools aren't able to do. So this piece of equipment is called a Stuska engine dynometer. It's their power track series that they have. It basically is what we call a water brake, or what the industry refers to a water brake. So this engine's actually tied to a couple of water impellers, and we push water against the back of the engine to a fixture that's attached to the crankshaft. And we can then run this engine, and we can run the engine at wide open throttle and provide a load. We can change that load and then measure the torque that it's produced, and then do some calculations for horsepower. It's also got quite a bit of telemetry built into it, so we can measure temperatures at 12 different temperature inputs, a number of different temperature inputs here, and pressure inputs. Really borderline's almost a scientific piece of equipment, maybe even doing more measurements than we probably are going to need at this point, but we wanted that future expandability and benefit to use it as we see fit in class. So the engine that we have on here right now is actually out of one of our motorsport dirt track race cars. This is kind of a unique piece. It's a sealed engine. That means we can't take it apart, so it runs a specific class. And we wanted to use the dyno then to get every bit of horsepower and torque out of it that we possibly could. And so we actually spent a number of hours last week making pull after pull. That's what we call when we accelerate the engine and make a horsepower and torque measurement, adjust an air-fuel ratio and adjust in timing to make sure that we could get everything that we could out of this engine. So this engine was rated by General Motors at 350 horsepower. Our tuning ability, we actually got this to about 375 horsepower and 424 or 425 foot-pounds of torque, again on something that was supposed to be rated at about 390 foot-pounds of torque. So pretty excited about that, and later this week actually this engine's going to go back in the car so we can be ready for spring. So what you can see here, we got the Filamentary going, we've got our engine running, you can see the horsepower, and we're down here at idle, so there really isn't a whole lot of measurement that's taking place. We're looking at oil pressure and fuel pressure. We've got our data to include so that we can do correction for horsepower and torque for the conditions that we've got today. So you can see the room is 77 degrees, 17% humidity, there's our barometric pressure. Here are our wideband O2 sensors. We're actually running this engine on E85. So a correct ratio mixture is really about 9.7 to 1. Those are things that all of these things are going to be recorded while we're taking our measurement. We've got our water temperature and oil temperature, and then here's our horsepower measurement. And so what's going to happen is that I'm going to set this up where we're going to make a measurement between about 3,000 RPM and 5,500 RPM, and then the machine will actually make a record and then plot some information on a graph. Okay? So what I'm going to do is I'm going to take this to wide open throttle, and the machine's going to pull us back to about 3,000 RPM. I'm going to say start measuring, and it's going to then change the load and allow us to get up to 5,500 RPM. At that point we'll shut it down and we'll see what our graph looks like. Right, so not very long at all. We can come over here and we'll only look at that last run that we made. And we'll change this. What we were recording on here before was actually our oxygen sensors to make sure that we were in a safe range. So here is horsepower and here is torque. And so we can actually then see the two lines here. The black line is horsepower and the green line is torque. So that run that we made, we actually had about 320 horsepower and torque. Horsepower was again about 350 and torque was in the 400 range. So that was the first pull that we've made today on that engine. It's a little cold. We would make multiple pulls and get an average. So an interesting piece, as I said, a great way for us to show people what horsepower and torque looks like, and we can make changes on the engine to see what those results are going to be.
Even though I've been around cars my entire life, I still felt the need to further my knowledge and get a degree. Parkland College was really close to home. John Ross really went up and beyond anything I expected from any instructor. He was able to place students in really good jobs.
Parkland College is tremendously affordable when we compare it to other schools that offer automotive technology or other four-year institutions. We have a motorsport program. We do an annual car show. We have 100% placement with our graduates.
The automotive program at Parkland was outstanding.
So the Park Hill Applied Technology Center is not attached to the main campus. While still on the property, one of the things that we needed to be concerned about was student space. And so this space that we're showing at this point has been dedicated to students having a place to sit down and relax, to have conversations with other students. We also have lockers for them to store their valuables, and then a couple of computer terminals so that maybe they need to catch up on an assignment or register or stay in touch with the community through email and so on. So again, student space was important. You can see we devoted a pretty good square footage chunk of this building to taking care of our students. So this is the machine tool lab in the Park Hill Applied Technology Center. While machine tooling is not a specific part of our automotive program, it is a valuable skill that we have here in our local community. A lot of our industrial partners need people that can use both the manual controls for lathe and mill work, and then as you can see that we also have a number of computer controlled machines, and students are going to learn a variety of aspects around those pieces. So as I said, not necessarily a part of our automotive program, but we do occasionally have a student that will look to advance their skills and want to learn how to use a lathe or a mill, and our machine tool program is where they're going to get that.
We were able to expand our machine tool lab. We have a lot of manual equipment and some new CNC that you see behind me. We were able to do a combination of keep our existing equipment and strengthen it with some new stuff. We have a new milling machine behind me here, and we also bought a new CNC lathe, and we're looking to expand into multi-axis turning, which would include milling and turning combination and live tooling, and also a little bit bigger format on our milling machine behind us. One thing that's not directly in this building, but this building made it possible, was when Automotive moved into this facility, we were able to move our industrial maintenance program into the former Automotive lab. So we have 7,500 square feet over there now that has industrial training equipment. We do a lot of training for local manufacturers, for their current employees, updating skills and bringing new technology to them. And also, of course, we're training our normal population in areas that will strengthen their experience when they do an internship. It's been great. We've been able to expand in our material sciences area. In the back corner of this lab, there's an atmospherically controlled hardening oven and also a tempering oven that we've been able to introduce some more advanced processes in material science. So we're doing some hardening and tempering of tool steels and other high carbon and medium carbon steels. So it's been great for our material sciences area as well. No, it's a great facility. We're fortunate that we have it, and we're looking forward to many years here.
So now we're in the welding lab of the Park Hill Applied Technology Center. A variety of different applications that students can learn from. Really some great new equipment, a great new learning facility. Hopefully we'll be able to highlight some of those pieces for you. Again, welding is not a required piece of our automotive training program, but we do find that students look to find those other skills, and we've got a variety of welding classes that students can take advantage of.
Oh my goodness, I was stuck in a temporary facility for, the program had been moved there when we came off of Willard Airport, and we'd been there a number of years, probably close to a decade, in this temporary facility, and this is just night and day difference. We can do so much more here. The building is designed for the program. It meets AWS, or American Welding Society specification. Each one of the booths is 6 foot by 6 foot. Again, American Welding Society specifications. Even the color of the room is to their specifications. We run all the most popular, or I should say manual, the most popular manual processes that are used in the industry. Beside me, to my right here, I have a MIG welder, used a lot in manufacturing. Behind it is a gas tungsten arc welder, or TIG, as a lot of folks know it. We weld all kinds of metals, sometimes exotic, sometimes just your standard steels and aluminums and such. I know in the last year we've added at least 5 classes, as I've all filled. We're able to run 2 classes at the same time, which was absolutely impossible to do at the other facility. We just split the lab in half. The equipment is really, it's new, but it's new in my eyes, but it wasn't new with the building. So what we have now is a state-of-the-industry facility that provides a very sound learning environment for our students, and a safe learning environment, because what I do, we play with fire. That's what we do. And temperatures ranging from 6,000 to 25,000 degrees. There's some inherent danger there, and so you can't hardly make a facility too safe. The administration here and the architects asked for a lot of input from all instructors, and a lot of it was used, and it's just great whenever you have input and then they actually utilize your input, and just wonderful. I pinch myself every morning when I walk in here. I just can't hardly feel like I'm dreaming sometimes. This is a beautiful facility, one that I really never ever expected to see in my career time. The administration here, they did wonderful things here, and I can't compliment them enough. Dr. Ramage, Dr. Young, right on down the line. I just can't hardly say enough. I just really appreciate what they did to make this happen, and it's great.
So now we're in the collision repair training facility of the Park Hill Applied Technology Center. Wonderful new space that we've got for training people in the collision repair industry. All the aspects of what they would be exposed to in the work industry we've tried to duplicate here. All brand new equipment for our students to work with, and so you'll be able to see a variety of projects going on at this point. 2 brand new paint booths and prep decks. Kind of a neat piece. We've separated those from what we would consider maybe the dirtier part of the industry, where they're going to do cutting and grinding, where you want to keep all that debris out of those paint jobs. And so actually a totally separate room to complete the paint jobs.
Had just overwhelming response from all the students as far as the ones that were at our old facility in comparison to the new. It's just been awesome. One nice thing is we're able to design this facility from ground up, so that's given us the ability to kind of create a flow to duplicate a shop environment. Where at the old facility we didn't have that ability, since it's been multiple other things prior to becoming the collision center. So this has been great, being able to, that's our primary function, was to duplicate shop environment. We were a 10-minute drive before over to the old collision facility, so this was good. A walk over to main campus, walk back over. We were having to address some of how our classes were set up just to accommodate that drive, especially for students that were on public transportation. We were able to, with the new facility, get new equipment. Some of that, especially in this area, which is a refinishing, we're one of the only or the few collision facilities in Illinois that also teach water-based paints. Because of our new paint booths, we have that ability to incorporate that into our curriculum, which we didn't have before. And obviously with economic changes, the environmental changes, water-based paints are undoubtedly the future of the collision repair industry. So for us, being able to bring that into the curriculum was great, because that's what the students, again, are going to be out there working with in the shop. So we have both. We have a solvent-based paint and also a water-based paint that we can utilize now that we were unable to. So, and also the frame area, we've got a larger, with where we were at, we were bound by how small we were, and so sometimes safety issues when we work on the frame rack, where we have a lot of pressures involved, was a little kind of scary with students around. So this way we've got more space, we're able to utilize the equipment better. And again, this is stuff that the students are going to be working with in the shops. So we've tried to incorporate equipment that is local. So not just locally purchased, but locally utilized in the shops that we put students in. It's just been a huge jump for us, the facility, being attached to Automotive, being attached to Welding. All of these are part of our program as well. So it brings us together, and that's been, for us especially, and for the students, the huge benefit. Having new is always great, but it's the little things in between that make the difference, and those small pieces of communication, and just it's helped us, it's helped the students tremendously. We started this project, several years ago, one summer, and we all sat down in a group, and we started basically ground up. And that's what was so nice about this facility, as far as being able to take what we know, what we've worked with in the industry, and incorporate that into what we knew the shops utilize. So our build was designed from a shop, and the equipment, again, was pulled from shop environment. So yeah, that's clear right down to the nuts, bolts, sinks, everything we were a part of. And that's kind of different, I know, in compared to some of the others that we've gone and visited. It was more of a turnkey. You just walked in and here's what you got, and you weren't sure what that was going to be. And in our case, it's been great being able to do the ground up firsthand.
Well, I really appreciate you joining us today in this episode of Parkland Garage. Hopefully you can see that there's been a reason why we've been silent for a little while. We've had a lot of work to do. fabulous facility. Hopefully you've seen some of the new technology that we're able to bring to our community. And as always, if you ever want to know more information about that, certainly welcome to come see us. A great way to contact me would be jross@parkland.edu. Thanks, and we'll see you again.